Hello, everybody. My name is Claude Juriens. I'm the Chief Business Officer of ecoRobotix. It's a pleasure to meet you this morning. I hope you are all doing fine, even in those very strange times. This morning, I'm going to present you our product and technology, thanks to some small video that we have recorded during the 2020 test campaigns. As you will see, those video are they have been really recorded on the field by our own technicians. So they are genuine, untouched videos. So if you want a very nice commercial video, please just go onto our website. And that's not the purpose of this morning. I will allow myself to pause sometimes on the video to have time to give you some more explanation. So let's start with some explanation about the ultra-high precision. So what do we mean with ultra-high? So at ecoRobotix, we are able to spray about such a pixel, which is 8 by 3 centimeter. So that's the footprint we have on the soil every time we open a nozzle. And we are able to position that pixel with a precision of plus minus 1 centimeter, still having a vehicle speed of up to 2 meters per second. So to achieve this, we are having 3 core technology. The first is the sensing. We are using camera technology, and then we are doing diagnosing. So we have AI algorithm on our onboard computer, which is able to recognize what is the crops and where are the weeds. And then the third brick is really acting, in which we have to calculate the movement and the speed of the vehicle to open the nozzle at the right time. I will not go in more technical details. If you want to understand more how it works, you can go onto our website, or I will present that more in detail this evening around 6 p.m. on the FIRA. We are able to do various crops, crops like sugar beet, rapeseed, string beans, rumex in Midlands. We are also working on new crops like chicory, salads, cotton, so onions. So for us, the purpose is to really have, as soon as possible, a complete crop portfolio. The technology bricks I just described can be mounted on various vehicles. Of course, the first one is our Avo robot. It's a totally autonomous platform. So both in terms of the energy, it's solar and battery powered. It's also autonomous in the navigation. So it will navigate on GPS, RTK, 4G, and also visual odometry. You have at the back of the robot, you can see the spray bar. So it's a 2-meter spray bar, and we have a nozzle every 4 centimeters. That is giving you this accuracy of 8 by 3. So 8 centimeters pixel on the width of the robot and 3 in the direction of the robot. The spray bar can be adjusted from 15 to about 40 centimeters. We embark about 120 liters of mixture, so water with a mix of chemicals. In 2020, we had about 5 of those robots doing many field tests in various countries in Europe. And thanks to that, we have gathered a lot of experience. So we have validated that we were really able to spray only the weed with the right accuracy, not spraying the crop. We were able to demonstrate that we were able to spare up to 80% of the chemicals, still maintaining a similar weed pressure as a normal system will do. But we also had, we have learned many feedback from the market. And one of the feedback that came very often was, why do you put that technology behind a tractor? And indeed, we tried. So we literally dismantled one of the robots and plug it as a proof of concept behind a tractor. That's what you can see at the moment. And guess what? It worked. Exactly the same accuracy like the robot, but with one advantage. it's the speed. We were able to go up to 2 meters per second, which is normally only one onto the robot. And that gives us an idea to say, fine, of course, the robot is important, we'll continue the development, that's maybe the future, but we can perceive that there is an easier market entry with a portable version, a tractor version. So out of that proof of concept, as you can see, then we have in 3 months, we have made a complete prototype, which is now finished in Switzerland. You will see video in our YouTube chain in the next weeks. And what we did is we multiply what you have here by 3. So now we have a 6 meter width system, and thanks to the 2 meters per second, we are able to do or to weed 4 hectares per hour. Again, I will present this new product this evening at 6 p.m. Now, let's continue really on the topic of this morning, which is really the test on the field and the video we have recorded with the robot. So here you have a map of the test, or some of the tests we have made this year. So we worked with KWS in Germany for the sugar beet, with Tereos in the north of France also for sugar beet. We had a pilot with Triskalia, this is the Juriens group, in string beans. And of course, many pilots in Switzerland, including a sugar beet test in the Swiss Future Farm, and pilots with the Swiss agroscopes, and of course, several farmers close to us. Now, we start with the string beans. That was at Triskalia. You can see also the precision here. So we are able to detect a weed as soon as it is close to 1 centimeter diameter, even a little bit less. And we can recognize the crop as soon as we have 2 true leaves. So depending on the crop, something like 5 centimeter diameter. You will see sometimes that the leaves of the crops is having movements, meaning that we have touch with the spray the crops. In those tests, our system allows you to choose between a total protection of the plant. So there is a protection area around each plant. But then in that case, of course, if there is a weed very close to the root of the plant, then we are not going to spray it. In those tests, we have chosen the possibility to spray any weeds, even if a weed is close to a plant, because we were using selective herbicide. But if you are using total herbicide, then we can make exclusion zones, and then the crops will not be touched at all. Thanks to the picture, you can also easily see that depending on the weed density, we can spare between 50 to 90% of the chemical usage. And this is also what we have measured with the third-party partners during the year. Really concretely, on a full season, we have been able to spare between 60 to 80% of the chemicals. Here you can see that we are also having no problem with bigger weeds. Now some examples on the sugar beets. Maybe here also important, this is just an example showing that we are able to selectively spray monocotyledon. So the graminae is no problem for our algorithm, even if the graminae or monocot weeds are pretty high. And you can see the nozzles every 4 centimeters. This video is a testimonial on our capacity to spray weeds which are very big, very much sprayed. So you will see it better when we take some distance. again, we haven't touched the video, so there is no trick at all. I'll just stop once we. Yeah. I don't know if you can see my mouse. This is an interesting example to see really what we are able to do. You can see the row of sugar beets. They are untouched. Also here, there are a row of sugar beets. So we don't touch the beets. So even this one, you can see that we are spraying before on the side, but not the sugar beet. Now, some example on the grass. So it's basically for the remix, maybe a few explanations before the video. Our algorithm, they are trained to recognize the crops. So, and then normally then we are going to spray the weeds. But even in the normal crops like sugar beet or rapeseed or string beans, you have the possibility to invert the actuation. So we still recognize the crop like sugar beet or rapeseed, but instead of spraying the weed, we can reverse it and spray the crop itself. This is very interesting in the case of insecticides, because when you have to spray on sugar beet, again, those are small bugs, it's when the sugar beets are small, so you have a lot of soil in comparison of the surface of the crops, and we are able to spray only the small crops. So you spare also a lot of products thanks to that when you have to spray insecticide or fungicides. In the case of Rumex or grasslands, of course, we haven't learned with our algorithm to recognize the grasses, but we recognize the Rumex, and now we are also working on distal, and we do also the reverse trick. So we recognize the Rumex and we spray on it. And this is an image. So here the grass was already quite big, but as you will see, that was not too much a problem. By the way, in that case, the robot is driving purely on GPS RTK. Below, you can see the flash. So that's not the water, that's really the flashing system. Here we are not spraying, so you can see that as long as there are no big leaves, we don't spray. Now the Rumex start to appear. And as soon as we see the Rumex leaves, then we open the nozzles, but just on the Rumex. Here you can see that pretty well. Nice job, baby. This is the result after 3 to 4 weeks, and we were using Alitap, so it's a product which is a total herbicide, so very aggressive on the Rumex. You can see all the Rumex. We have 95% of the Rumex that were just destroyed, and the Alitap is also very aggressive for the grass. And as you can see, we had very little damage on the grass itself, but all the Rumex, they were killed. And that's really basically what we are doing here, is we are replacing the grandfather with the manual spraying tool going onto the field, onto the lands. Yeah. I just stop the video presentation. So in a summary, during this year, we have demonstrated the capacity to really reduce the chemical usage by easily 60 to 80%. We demonstrated that we were able to spray only on the weeds. This has the following advantages. First, there is less, there is no or less residues onto the good crop. There is the yield increase possibility because there is less phytotoxicity on the plant. That is clearly showing that in the future, with the exclusion zone, we will be ready to spray total bioherbicides. And also, we are ready to spray insecticides. So in terms of the schedule, we are going to produce next year about 10 AHA, so the tractor version, to continue agronomic tests. So that's it about for my presentation. So maybe we'll leave the door open for your questions. Any questions? Oh, yes, there are. Oh, I'm too old for that, so I need to take my glasses. Okay, I have a question from Matthew. So what is the limiting factor on speed, detection, or application? Yeah, on the tractor version, we are not limited by, of course, the speed of the tractor and the power. So at the end, it's the processing power of the video cards, because we have only 1 meter distance between the center of the camera and the spraying bar, and we are taking several images per second. Question. Yeah, the detection is based on machine learning and training. What is your main argument to still develop the robot version instead of the tractor combined version? Davide, oh, that's a nasty question. That's a good question. The future will tell. We still believe that there is a nice market for the robot. Let's see also how the tractor manufacturer will develop a lightweight electric autonomous vehicle, not to be in competition too much with those guys. We believe in for sure that there is a market also in the future for the robot, particularly for the mechanical tool, because with the mechanical tool you have to go a little bit slower, and then the price and the cost of the driver and the tractor starts to hit the economical model. Are you using several herbicides families in order to prevent resistance? Well, we are just a tool. So at the end, the music you are going to play with our instrument is up to you. So we are agnostic of the type of product. So this is also something that we are going to learn in the next years, is what is the best chemical to use in spot spraying. That we are working with various partners in the chemical industry on that. How is the robot guided? Only RTK GNS? No, it's both. In the grasslands there is no row, so it's purely GPS RTK navigation passes. On the row crop, it's both. It's the generic navigation is made with GPS RTK, but in addition to that, we use visual odometry. How do you see the future of ecoRobotix? Oh, very bright, for sure. I don't know. Is there more to answer like that? I think the core of ecoRobotix, of course, is the bricks I described, and this can be fitted into various tools. We see also that it's very difficult to detach the core, so the vision and the actuation, with the tool itself. The spray bar we are using is not the spray bar you will normally have on a normal sprayer. So we had to also go up to the tool itself. For the rest, we will certainly also partner to go with a bigger machine. So we see us in the future concentrating on the core, still selling complete systems, both tractor and robots, but maybe partnering more to increase the final product range under our brand umbrella. As it is a field robot that does use spraying system adaptable to orchard with some modifications. Yes, but in that case, this is what I just mentioned. It will be a partnership with somebody who has a vehicle for orchards. So we are not going to do vehicle. That's not what we are good at. Certainly in the future, but not in the next 2 years. Wow, there are many questions. Okay, okay, the FIRA told me that I have 30 seconds. Please conclude. So I'm really sorry, maybe I take a very last one. Is it possible to use the robot when the crop is a bit bigger than in the video? What about the accuracy of the spraying if the camera is higher? Of course, the pixel becomes bigger, so we can go up to 45 centimeters, but it's definitively possible. So thanks a lot for the hundreds of very interesting questions. I am really available the next 2 days on our booth. Please come back to this. And I really thank everyone for your attention. And I give now the video back to the FIRA organization. Okay, bye-bye, all the best, and looking forward to meet you on our booth.